Did you send it to me? What did I tell you? Send the question. I told y'all, all you gotta do is hit a button. Now I gotta go look it up. Hold on. I know things are difficult in my class. Well, I done lost it. Okay, what happened to my, didn't I have it pulled up or did I X out of it? I guess I X'd out of it. Okay, it's gonna be one of those days, people. Oh, I said I didn't need it. Now I do. Okay, let's go to grade book. Miss Battles. Which homework? 6.6. Okay, you haven't done it yet. Huh? Ah, you did the study plan. Okay, that's why. Okay. So let me go to the study plan, and I'll pull one up just like it, baby. Go to main menu, study chapter contents, 6.6. Study plan. Do you remember what number it was? 29. Okay, we haven't done this yet. Remember I told you don't do any graphing problems?
Yeah.
That's probably why. Is the homework assigned yet?
No.
That's why. Because I didn't want
was
y'all.
curious.
Yeah, that's fine. We'll do it. That's fine. But that's what we're doing today. And that'll lead into today's class. So let me go ahead and pull the whiteboard up. We're going to go over the 3 methods of graphing, and that's going to be it as far as the 6.6 test. So, what'd you say?
The 6.6 homework.
Oh, what about it?
Would you give it out already?
No, I'm going to assign it today
Oh.
after I get through with the unit. Or after I get through with the section. The first method of graphing. These are how you graph a line. First method is what I call the chart plot method. Now, it's called in your book using graph using points, graph using ordered pairs, or graph using coordinates. Okay, that's what the book uses or other books use, but I call it chart plot. You use this method, and this is in red, when y is by itself. Now, before I go on, there's always a student out there that says, well, I just use one method, I don't care what it looks like. You're the kind of person that uses a screwdriver for a hammer and a hammer for a screwdriver. Mm-hmm. Huh? What?
I accepted it.
Oh, I thought that was you. In other words, each method that I'm showing you has a reason. There's a reason I'm showing you that method. It's not because I want you to get mad at me. It's not because I want you to take the long way around. It's because that when y is by itself, you use method 1 or method 3. When y is not by itself, you use method 2. It's as simple as that. But you get some people that think that, I don't know what they think, but anyway, I'm showing you the three methods because they're used at certain times. All right, what do you do first? Well, the first thing you do is you solve for y. Make sure that if the directions say use points, use ordered pairs, or use coordinates, and they may not give you y by itself, but the directions tell you to use that, then you have to solve for y first. Okay, now let me go ahead and say something else. If the directions tell you a certain method, there's 4 types of directions on this test and in this homework. If the directions tell you to use method 1, which is coordinates, points, or ordered pair, then you have to use method 1. If you don't, then you're going to get the answer wrong, and you're going to check to see what your answer is, and guess what? It's going to be the same thing. The line's going to be the same. And you're going to get mad at me, and you're going to say, well, you didn't do the right method. 2, if it says graph using intercepts, then you have to use the intercepts. If you don't put the intercepts, it's going to mark it wrong, even if the line is right. 3, it's going to say graph using the slope and y-intercept. If you don't use the slope and y-intercept, it's going to mark it wrong. Now, what if it just has the words graph? Then you can use any method you want. Okay, so that's the 4 types of directions you're going to get on this homework and this test. It's going to tell you the graph, use any kind. It's going to tell you to use the 3 kinds. So I'm going to go ahead and get that out of the way because I don't want anybody hollering when they get, you get an X and you got the same line. Okay? First thing you do is solve for y. Second thing you do is draw a chart. I call it a chart. You call it what you want to. And when I put the chart up here, you're going to say, oh yeah, I did that back in pre-algebra. Draw a chart. 4 or 3. 90% of the time, I will pick these numbers for x. -2, -1, 0, 1, and 2. 10% of the time, in other words, 10% of the questions you get about graphing with this method, I'm going to use multiples of the what? Denominator. So that means it's got a what in it? Fraction. Okay. Now, focus on these. Why am I going to use those numbers? Why don't I use 100, 101, 102, -100, -102? Why do I pick those 5 numbers? No. I think I know what you're talking about there, but that's not why I picked it. Why did I pick those 5? Smallest numbers are easier to what? Calculate. Small numbers, that's 1. What else? Huh? 2 what? 2 numbers on each side? What'd you say? I didn't use. Why am I using those 5 numbers 90% of the time? Why don't I use other numbers? Okay, you've got both negative and positive on both sides, so that's the second reason I use it. What else? Why? Why do I use 5? Well, how many points does it take to make a line? How many does it take to screw it up? So why do I use 5? Hey, gum, I have conditioned you, haven't I? Because if you mess up 1 point, you still got how many you can lay on? 4. That's why I use 5 points. And the 5th reason, that's 4 reasons, the 5th reason or the 4th reason is because when you move on, or if you're asked to graph a nonlinear, which is a curve, you have to use at least 5 points. So that's why I use 5 points, just in case, you know, small numbers, positive and negative, the origin, 5 points, and 5 points are used later on for a curve or nonlinear. So that's why I use those 5 numbers. Okay?
And that was for X, you said?
Yes. For X, yeah. 90% of the time for X.
Then, what's that for the number?
Denominator. And this is for X. So over here, this is what y'all do though. This is what y'all do. Y'all see what y'all do? Here you go. 0, 5, 2, or -1. That's what y'all do. That's what students do. I've seen it over and over and over. I don't know where y'all learn to read, but I've never seen somebody read like this. There's no sequence. There's no sequence. It's just all over the place. No wonder you're confused. And I don't mean y'all, I mean students. I've seen all kinds of weird stuff. Which way do we read? -2, -1, 0, 1, 2. Simple as that. Number 4, plug and what? Plug and charge. And I love it when somebody says, "What do we plug in?" I don't know. We only have 5 numbers right there. The only numbers that I've given you. And 6 clock points. Oh, I'm sorry. I'm on drugs this morning. 5 clock points. Now, before we do this, I want everybody to take a page, the back of this page or the front of the next page. And I do this with all my 155, all my algebra classes. I do this, so I'm not picking on y'all. I want you to do the, hold on, I gotta remember how to divide, do a landscape, and divide your paper into 5 or 6 sections on top and bottom, which means about 10 at least.
Can we just use that?
You can use anything you want to, that's fine. I'm just,
Basically, that's what
yeah. I want you to do this, put it into at least 10 sections. In each section, I want you to draw the X and Y chart. Each one. And leave some space at the top so you can write an equation. We're going to do a little drill here so none of y'all go stupid on homework. Y'all seen Patrick Starfish when Squidward asks for his order and he goes, "Oh." I watched Patrick last night. I got bored. There was nothing on TV. I did a dash to the 80s last night. I watched Rambo 1, 2, and 3. I was back in the 80s, going back to high school.
Have you watched Gold?
No, I don't watch sitcoms. I don't like it. I don't like them.
them.
Oh, well, yeah, that's great. I mean, I wouldn't mind watching it, but I don't do sitcoms.
Because it's so definitely
The 80s.
Oh my God.
The 80s was great.
My son laughs, we watch it together with him. He just thinks it's great.
I think the 60s and 80s was great. The 70s was awful.
I like the music.
The 90s was awful too, as far as the music. And I don't think music has been much better since then. I think the 80s was the peak. I think the 60s was the peak of music and the 80s was the peak of music. I don't think there's been a peak during the 90s. It was pretty much, everything was emo.
Country music.
Early 90s, but then it got stupid.
Yeah, that's what's.
Now country music is stupid. I don't even put it on a country station anymore.
I think this is depressing.
No, country music is not depressing. There's a lot of country music that's good. Real country music. Now that crap they play now. It's not country. It's emotional something. I don't know what it is.
That's what I mean.
Pop.
That's what I mean.
Pop something. I don't call it pop country because there is no such thing. People say, well, how do you discern whether it's real country or old country? I said, well, you just ask yourself, the person singing, if you would go to a redneck bar with them. Would you go to a redneck bar with Toby Keith?
Yes, I would.
Would you go to a country bar with George Strait?
Yes, sir.
Would you go to a country bar with Rascal Flatts? No, because you get your ass beat. Now, wouldn't you?
Have you heard?
I'm talking about a real country redneck bar. I'm not talking about one of these, like, I'm talking about a real country redneck bar. Metal detector at the front door, you know. No, you wouldn't walk in there with Rascal Flatts. You wouldn't walk in there with, you'd walk in there with, what's his name? Oh, gosh. Trace Atkins. You'd walk in there with Trace Atkins.
You're just thinking.
Yeah, I've tried. I've tried, but
Makes me think of the old days.
yeah, the only ones I listen to is Brad Paisley and before, which includes Trace Atkins, all them, what's his name, Alan Jackson, George Strait, Clint Black. You know, Clint Black's from California, so he's not really country. I'll shut up. All right, now I want everybody to write this. Up at the top, y is equal to 1/2 x plus blank. Y is equal to 1/3 x plus blank, and so on. Y is equal to 1/4 x plus blank. Y is equal to 1/5 x plus blank, and go all the way to wherever you run out of sections. And each one has one of these. The x and y. Oh well, the x and y at the top. Do that for all 5 sections, or 6 sections, whatever you have. Now I go through this drill with each one because I want everybody to at least have in their notes what to do if you have a fraction. Because I can tell you today, and when you do your homework the day before the test closes out, or the day after the test closes out, or whatever, whenever you wait till the last hour to do your homework, you're going to forget it. Ain't you? Yeah. So write all those 8 things down. And then pick points for the first one. -4, -2, 0, 2, 4. What about the 3s? 6, -3, 0, 3, 6. What about the 4? -8, -4, 0, 4, and 8. -5, -10, I'm sorry, 5, -10, -5, 0, 5, and 10. 6, -12, -6, 0, 6, and 12, and so on. So let's do this first one. You start off with -1/2, and then I put a 3 in there. Well, 4, what's half of -4? -2 plus 3? So you come out with a whole number. You would be surprised on how many people I show that to using multiples as a denominator, and they say, I've never seen that.
I've never seen this on.
Well, that's how you avoid getting a fraction, because if you plug in a 1, you're gonna get 1/2 plus 3, which is 3.5, which is 5/2. You're gonna have another fraction. And people don't like that. What's half of -2? -1 plus 3? -1 plus 3,
Sorry,
2. 0 plus 3, and you start to see the pattern, and once you get to the last two, you can fill it out with the pattern. 1, 2, 3, 4, and what? 5. And now you can fill in the other ones if you want to, with numbers, if you want to, that's up to you. But the main thing I wanted you to see is if I did 1/7, y is equal to 1/7 x plus 1, what would my numbers be? -14, -7, 0, 7, and
I have a question. How do you figure the numbers in this one?
The x's,
Yes.
that's what I'm telling you, that's what this is for.
No, I'm saying now since it's bigger than it's -4, -2,
Multiples of the denominator.
2. Okay.
Hey, count by twos.
2, 6, 10. I got you.
I just applied the negative and 0 and positive, just like on the 90%, the negative, 0, and positive.
Well, I want to make sure that I understood that properly, but what I don't get is, I know that you're taking the 3 from the -4, 3 from the -2, but when you got to the 2, how did it become 4?
I just looked at the pattern. 1, 2,
Okay, so
3,
you
4,
stop adding
5.
it then.
Well, you can. What's half of 2? What's 1 plus 3? So you can still add it if you want to.
I got you.
What's half of 4?
2,
2 plus 3?
5, got you. Okay.
So you do this one. Do 1/7 plus 2. 1/7 x plus 2. I'll let y'all do that. And see, if you fill out this whole sheet, that's extra practice for you. And I tell you what, why don't we do 9? And I'm gonna pick a 1. And I'm gonna jump a couple, and I'm gonna say 12. Do those 3 on the bottom. 1/7, 1/9, and 1/12. What numbers am I gonna pick for 9? 9 and 18. What about the 12? Maybe 12, 0, 12, 20. Now do that math. Alright, so what is what is negative 14 over 7? I'm sorry, negative 2. Negative 2 plus 2? What is negative 7 divided by 7? Negative 1. Negative 1 plus 2? 0 plus 2, because 0 cancels that out. 0 plus 2 is, and you see the pattern. So let's check the last one. What's 14 divided by 7? 2 plus 2? What's negative 18 divided by 9? Negative 2 plus 1? What kind of 1? Negative 9 divided by 9? Negative 1 plus 1? 0 plus 1? And then you see the pattern. Negative 1, 0, 1, 2, 3. Let's check the last one. What's 18 divided by 9? 2 plus 1? Let's check this one. What's negative 24 divided by 12? Negative 2. Negative 2 minus 2? Negative 4. What's negative 12 divided by 12? Negative 1 minus 2? You start to see the pattern. Yes, that's a negative. This thing is messing up. 0 minus 2? 12 divided by 2? I'm sorry, 12 divided by 12 is 1. 1 minus 2? And now you start to see the pattern. What's the last one? And that's the way you do the chart plot method. Now, of course, if you're given a whole number, you just use negative 2, negative 1, 0, 1, and 2. We'll do one of those next. But I wanted to address the fraction because I always do that drill right after I talk about doing the common denominator. So I went ahead and I put it on the board. Y'all got it written down. I'm going to go back to the previous screen. Now I'm going to make this small. We're going to do a couple more problems, examples. All right, try this one. Y is equal to 2x minus 6. And I want you to plot it. So if you got some graph paper, draw an x and a y axis and plot the points. If you don't, just draw 2 straight lines, x and y, and do the best you can. All right, what's negative 2 times 2? Negative 4 minus 6. Negative 1 times 2. Negative 2 minus 6. Negative 8. 0 minus 6. You start to see a pattern? So what's the next one? 8, 6, 4. Let's check the last one. What's 2 times 2? 4 minus 6? Negative 2. So negative 2 and 10, that's not going to fit on our thing. Negative 1, negative 8. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 0, negative 6. 1, 2, 3, 5, 6. 1, negative 4. 1, 2, 3. 2, negative 2. And you can see that line. And that's how you do the first method of graphing. Now, everybody in here should be saying, oh yeah, I remember that from pre-algebra. Because that's the first method that they showed you. Everybody finish writing it down. Everybody got it? All right, the second method of graphing. Second method is called the intercept method. And it's used when the directions say graph using intercepts. Or it will say graph using X and Y intercepts. Okay, it's going to say one of those two things. So if you have the directions and the directions say graph using the X and Y intercepts, you have to use this method. When do you use it? When Y is not by itself. The first thing you do is draw a table. Table is a little bit bigger than a chart. It's going to take up something like this. Two intercepts. Over here, I'm putting the x-intercept. 0 for y. Over here, I'm putting my y-intercept. 0 for x. Now, the reason I teach this method is because you need to know it. And the other reason I teach it is for this. From here on out, whenever you want to find in any math, any science, any business, any marketing, any kind of meeting, if you want to find the x-intercept, you plug in 0 for y. If you want to find the y-intercept, you plug in 0 for x. Whether you're in trigonometry, calculus, Underwater firefighting math, doesn't matter. Accounting 101. If you want to find the x-intercept, you plug in 0 for y. If you want to find the y-intercept, you plug in 0 for x. Biology, chemistry. That's why you need to learn this method. Not because you need to get an A out of this class, but because to find the x and y intercept of any application, you plug in 0 for the opposite that you're looking for. I'm going to give y'all an example here because I need to put it in here for the problem to show you how to do it. I'm going to do 2x plus 3y is equal to 6. Okay. And 3. Line up equation on each side. Now watch what I do here. What did I do? Yeah, I put it on each side. That's what, right here, each side. But what did I do besides putting it on each side? I lined it up to where all you got to do is visually drop that 0 there where the y is and drop what? Where the x is. Now, you can do this visually or you can do it mathematically if you pick the paper and pencil. Some people do it visually and just cover up the term with their eyes or with their finger or with their pencil or with a piece of paper. They just cover it up and then solve it. But I'll show you how to do it mathematically because that's what I need to do. So 2x plus 3 times 0 is equal to 6. 2 times 0 plus 3y is equal to 6. And what happens to the 0 terms? And now you're left with 2x is equal to 6. And 3y is equal to 6 divided by 3 divided by 2. And over here, x is equal to what? And what is y equal to? Oh, I forgot to put 5. Plug and chug. Or 4. Plug and chug. And 6 would be plot what? 6 would be plot your 2 points. Okay? So do that. And I'm going to take my handy dandy inserter. Y'all are impressed, aren't you? And I'm going to take my, since I finished it in blue, 3 and 0. Now, why do I put the word x-intercept and y-intercept over the points? Do I do it just because I want to waste lead, or do I do it for a reason? Do it for a reason. The number one mistake on this type of problem, anybody want to guess what it is? Putting it on the wrong axis. So that's why I put the x-intercept and the y-intercept above it. So now I know this is going to be on the what axis? X-axis. So 1, 2, 3. And and 0 and 2. And then I take my handy dandy line maker, and I'll make a blue line. If I can do it with eyesight. And that's how you do it. Now, this is the fastest method, but what comes, it's robbing Peter to pay Paul. If you get something that's really fast, what's wrong? It's easy to mess up because you only got how many points. You can do a checkpoint. Just pick x is equal to 1, plug it in, and see if you get the y. Simple as that. You could also pick a point. Like, find a point on my screen up here where it looks like it hits a corner of 2 boxes. I see one. -1 and 3. Plug in -1 and see if you come out with 3. So let's plug it in. -1 times 2 is what? -2, Hubert. Bring it over, that'd be a 8. 3 divided by 8 is 2 1/4. So I might be off a little bit with my graphing. You can't go by my graphing because those are 2 BA dots. You need to see, it's easy to make a mistake when you're talking about the intercepts. All right. Luckily, your homework will be you move the arrow and you pick the point with the mouse, and it's dead on. You ain't got to worry about a pencil, so you really don't have to worry about a check mark anyway. Okay. The main thing you need to get from this method is that if you want the x-intercept, you plug in 0 for what? The y. If you want the y-intercept, you plug in 0 for x. That's the main reason I teach this. It's for other applications in other courses. Okay? And that's the second method. Chances are, if I give you 10 problems on this test, 3 of them is going to come from one method, 3 of them is going to come from another, and 4 of them is going to come from another. So it's going to be, 80% of this test, the 20% is going to come from the first, calculating the slope or finding the slope and finding the equation of a line. Those are the 2 questions from the other section. And the rest of the test is going to be on these 3 methods. So you can do the math. How many questions I give you, every 10 or 15 questions, you're going to get mostly these 3 methods. All right, so let's try another one so you can practice it. Let's try 3x minus 4y is equal to 24. I'll try that. Now, of course, if you already know how to do the intercept method your way, and you get 10 out of 10 problems right, you knock yourself out. So, 3x, well, I'm just gonna show you what people do when they don't do it algebraically. They just cover this up, and they just write down 3x is equal to what? They don't do the actual plug it in, they just cover up this term because what happens to it? It goes away. And some people do it without even writing the table, and that's fine. If you can walk without falling down, then keep what? Keep walking. If you fall down 5 or 6 times, you might need to practice a little bit more. This goes out, cover it up, use your pencil or write it and mark it out. You get negative 4y is equal to 24. Very common mistake. Students leave off the what? You can't do that. I guarantee you somebody in here probably did it, but it's normal. X is equal to what? 8. And y is equal to, huh? Good. I'm gonna make these 2s. 2, 4, 6, 8. 2s. So, 2, 4, 6, 8, 9, 8. Negative 2, negative 4, negative 6, negative 8. All right, so our x-intercept is 8 and 0. 8 and, let's see if I do a little dot. No, I want to do a big dot. And 0 and negative 6. So I take my handy dandy line maker. Probably be blue. Good. Golly molly. What was that? Damn Russians. They just that don't get into everything, don't they? Y'all gonna be impressed, people. I know. I ain't had any training. That's why all these boards are sitting in the classrooms up at Pendleton campus and nobody can work them. Just sitting. And the ones that can work them, they just use them to present. They don't draw on it, they don't do anything. And that's how you use method 2. Now method 3 is real easy because most of you learn method 3 because the high schools don't want to teach method 1 or method 2. They want to teach method 3 because it involves no math. So therefore you do better on the test. You didn't hear that from me. Method 3 is called graphing. Graphing using the slope and y-intercept. I call it building a line. They call it graph using slope and y-intercept. Slope and y-intercept. When do you use it? Well, I use it when y is by itself. And you also use it, I use it when m is a fraction. You know how we use multiples of the denominator with the first method? Well, this one is a whole lot easier when you have a fraction. But when can you use any method you want to? When the directions say graph. When it says graph using the slope and the y-intercept, you have to use this method. All right? What do? 1, make sure that y is solved for y. Make sure that you have the equation solved for y. Because again, they may give you this direction, and they might give you 2x plus 3y is equal to 4, and you have to solve it. 2, extract. What does extract mean? Think of a tooth. Pull it out. Extract info from, and I'm just going to put it in this form, y is equal to mx plus b. I'm going to give you an example here. Ex, y is equal to 2x minus 3. So in this case, y is equal to 2x minus 3. I'm going to rewrite it as 2 over 1 because there's not a fraction there. So you make it a fraction, and then I extract the information. 1, y-intercept. What is our y-intercept? Well, it's whatever this number is right here. 0, comma, negative 3. So I'm going to take my handy dandy highlighter, and whatever this number is right here, it's going to go right here. Because that's your y-intercept. So there's 2 ways now to find the y-intercept. B. The second thing you find is your sine of m. Now the sine of m, there's going to be 2 options. It's either going to be positive, that means the slope is going left to right up, or it's negative, left to right down. It's either going to be one of those 2. So I take my handy dandy highlighter and we'll color it aqua, and I'm going to highlight this area right here. If there's nothing there, what is it assumed to be? Positive. So that means this one is going what? Left to right up. And then vertical over horizontal, C, vertical over horizontal is equal to 2 over 1. And that's that area right there. So I'm going to get my highlighter, color it green. So that's the 3 things that you find. Vertical over horizontal. 3. Plot y-intercept. 4. Draw a trace line. A trace line is something real light, and it's going from left to right up or left to right what? Down. That's what this is for. And then 5, plot vertical over horizontal from origin. I mean from that y-intercept. Plot vertical over horizontal from the y-intercept. Okay, so I'm going to bring in my handy dandy graph paper after I make this a little bit smaller. And like I said, most of y'all probably have seen this before because it's what they love to teach. Just like they teach the quadratic formula, but you don't even use it in calculus. You use complete and square, but they don't want to teach complete and square because it makes the students have to think with their brain instead of the calculator. So bringing in my handy dandy graph paper. And I'm gonna kind of blow it up a little bit. I'll get it in here. All right, the first thing I do is I plot my what? Plot my point. I'm gonna plot it with the highlighter so y'all can see where everything's going. The yellow is 0, -3. 1, 2, 3. There's my yellow point. I'll make it a little bit bigger. There. So that's done. I'm done with the yellow. I'm done with that. Second thing, draw a trace line. So I'm going to take my handy dandy straight line maker, and I don't have a light color, so I'm going to use yellow, because you would use your pencil if you were doing it real light, or use a yellow highlighter or something to show you. I'm going to draw it about a 45-degree angle. Doesn't have to go through the point. It can go anywhere around the point. But which way is it going? Left to right, up. Now, how do you know it's going left to right, up? Because which way you've been reading all your life? Left to right. Put your little car down here. What is that car doing on the left side? It's going up. Or it's going to go down. One of those two. Depending on its positive or negative. This one's going up because that 2 is positive. Wait a minute. I used the wrong color. I need to use blue. So let me go back and change it. The things I do for y'all. You can draw it shallow. You can draw it even shallower than that if you want to. You can draw it steep. It's just all of them are going left to right, what? Up. Okay, now, the green, start from the, hold on, I'm going all over the place. No, I don't want to use that. I'm going to go back here. There we go. No, I need to use the highlighter. I'll use this green right here. Okay. Now we're going to take our green here, and I'm going to start from the y-intercept, and you're going to go down or up? No, we ain't going up. You can go down or up. You can go vertical. Vertical is down or what? Up. This is vertical. I can go down or I can go up. Which one you want to do? I'm going to go down because most of y'all are going to say up because y'all think you have to go up. You don't have to go up. You go down. How many times you go down? 2. 1, 2. Now I want you to look at that green dot right there and tell me where the trace line is. To the left or to the right? Y'all don't see it right there? It's right here. That's where the trace line is, right? Go to the right. Right of this. Is there any trace line over here? No. So you have to go which way? To the left. Now this you have to go because there's a trace line. You have to go here. If you go over here, you're going to chase nothing. So I go down 2 over what? Down 2 over what? 1. So down 2 over 1. Down 2 over what? 1. So I want to go up 2 over what? Up 2 over 1. Up 2 over 1. Do it all day long. And now that I've established my green points, I take my green line, because that means I'm done, and I draw a real line. And after I draw that line, what do I do with the trace line? Delete it. Or tell the thing to get, where's the, well, anyway, thought I could hit delete. There it is. Delete the trace line. Yeah. There's your line. And that's how you do it. The number one mistake students have with this problem is some idiot brain teacher has told them that they have to go negative and they have to go to the, if it's a negative, you have to go down. And if it's a positive, you have to go up. No. The negative only establishes one thing. Left to right, what? Down. Once you do that, all you got to do is follow the trace line with your vertical over horizontal. That's all there is to it. Class is over, right? What time's class over? 2:10? All right, well, is it 2:10? What time's class over? All right, well, y'all can work on the homework. Send me questions if you got them, because Monday we're going to review for the test on 6.6. So send them in, and I'll assign it right now. Let me do it right quick before I forget. Let me turn the two-jigger off.